Let us study modern periodic table. Who made modern periodic table? Moseley, Henry Moseley. In which year? 1913. In 1913, Moseley developed a new periodic table. That periodic table is known as modern periodic table. Modern periodic table has got one more name, that is long form of the periodic table. When what is meant by he himself given or he himself made a periodic law. His periodic law is known as modern periodic law. Now let us study what is modern periodic law. Modern periodic law as well as Mendeleev's periodic law are same. What is Mendeleev's periodic law? Mendeleev's periodic law states that the properties of elements are the periodic functions of their atomic masses. Now, what is modern periodic law? Modern periodic law states that the properties of elements are the periodic function of their atomic number. He proved this with the help of a demonstration done by using an X-ray tube. He said that in an atom, at its center, there is nucleus. Just imagine, this is the atom. At its center, there is nucleus. In it, positive charged particles are there, to them known as protons. Then, chargeless particles are there, to them known as neutrons. Around the nucleus, there are number of orbits, that is depending upon the elements. Each and every orbit there will be electrons. First orbit of an atom has or atom can occupy maximum 2 electrons. Then next can have maximum 8 electrons. Then depending upon the atoms there will be number of orbits. So starting from first or starting from one orbit, at the same time ending with 7 orbits. Maximum 7 orbits only will be there to an atom. Now we are going to study about details. How did he make his periodic table? So first we will study what is his periodic table. How did he make his periodic table? So before showing that, I am saying you once again what is modern periodic law. Modern periodic law states that the properties of elements are the periodic function of their atomic number. Now one more thing I am saying you, atomic number is the fundamental property of modern periodic table. Modern periodic table made by a scientist, his name is Henry Moseley. Before Henry Moseley, you people already studied about Dobrynin's triads, Newland's octaves, Mendeleev's periodic table. Now the last and final table, that is modern periodic table made by Moseley. How did he make his periodic table? We will study. We can say that it is a complete periodic table. I already prepared that table. Just I am showing you that. This is modern periodic table. Here you can see total number of 118 elements. 118 elements you can see. Now here total number of periods. Periods means a horizontal rows you can find is 7. Now there may be a doubt from your side, then downside also you are finding periods. But these periods, this is not a separate period. These elements are from here and these elements are from here. Now why did they kept them separate? Because from 57 to 71 these elements are there. These all elements are having similar properties. So to them kept in separate row. Again 89 to 103 these elements are having their atomic number. Even these elements are having such a similar property, because of that to them kept in separate row. But from lanthanum till lutetium, these all elements are belonging to 6th row. So we can say that they belong to 6th period. Now you see here actinium, from actinium to lawrencium, these elements, total 15 elements you can see. These all elements should be there in this place. But why he put them in separate row? It's meaning these all are having similar properties. But they belong to 7th row. Now another thing what I am saying you, when we study about the groups, groups means the vertical columns of the elements are known as groups. Here total number of groups, when we count 1, 2, 3 like that, if you are counting, I even written the number of them. Each group's number I written. All these groups together you will find total 18 groups. So we can say that in modern periodic table there are 18 groups, 18 vertical columns, and there are 7 horizontal rows. So we can say that horizontal rows are known as periods, vertical columns are known as groups. Now again I am saying you some naming work also we have to do now. The first group and second group together we can say as S block elements. First group and second group elements are known as S block elements. Now this side, that is group 13 to group 18 are known as P block elements. So first group and second group together known as S block elements. You people already studied, same thing I am repeating now. So first as well as second group is known as S block elements. Then 13 to 18 group elements are known as P block elements. Then middle you can find that this condition, how many elements are there in this place, how many elements are there. That means group 3 to group 12, how many elements are present, to them calling as D block elements. So group 3 to group 12 known as D block elements. Now another question, here two rows specially arranged condition we can see the elements, to them known as F block elements. So first two group of elements are known as S block elements. Then last, that is 13 to 18 group elements are known as P block elements. Middle, that is from third group to 12th group elements are known as D group elements. And last, in separate condition, two rows of elements you can see, these elements are known as F block elements. Now another thing, the first group elements we can call as alkali metals. So here first group of elements are known as alkali metals. Second group of elements are known as alkaline earth metals. So first group elements are known as alkali metals. Second group of elements are known as alkaline earth metals. Now here this 17th group elements are having other name, that is halogens. So 17th group of elements we can call as halogens. Then 18th group of elements we can call as noble gases or zero group elements. So once again, first group of elements we can say as alkali metals. Second group of elements we can call as alkaline earth metals. Now here 17th group of elements are known as halogens. 18th group of elements we can call as zero group elements. Now here downside if you are coming, This first row of elements we can call as lanthanides or lanthanide series. Then second group here, these elements we can call as actinides or actinide series. Now, and one more thing I am saying you, here if we think of first row elements, that is first period elements, their outermost orbit has, or they will be having only one orbit. Second group, if we are thinking of second row elements or second period elements, they will be having two orbits in their atoms. So, first row elements will have only one orbit in their atom. Second row elements or second period elements will have two orbits around their nucleus. Now, third row elements, if you will see, in their atom will have three orbits around the nucleus. Fourth row elements, if you will see, they all will have four orbits around the nucleus. Fifth row elements, if you will see, they will have five orbits around the nucleus. Similarly, sixth will have six orbits. Seventh period will have seven orbits around the nucleus in their atoms. Now, if we will think of group, here in a group how many elements are there? All of them will be having same number of electrons in their outermost orbit. Now suppose hydrogen, it has only one orbit, but its outermost orbit has only one orbit that has only one electron. Now lithium, this is lying again in the same group. This is also having one electron in its outermost orbit. Then next element, that is sodium, its also outermost orbit has same number of electrons. Similarly, all the elements which are present in the first group have same number of electrons in their outermost orbit. But here one difference is there, that is the number of orbits are not same. Number of electrons present in the outermost orbit is same, but the number of orbits present in each and every element is different, depending upon the period where it lies. For example, the first period, hydrogen is lying. Hydrogen is lying in the first period, so it has only one orbit. At the same time, potassium lying in the fourth period. It has 4 electrons, 4 orbits. Here you see, hydrogen has only one orbit. It is lying in the first period. After that, potassium, if you are seeing, it is lying in the fourth period, so it has 4 orbits. Now, if you are thinking of francium, Fr means a francium, it is lying in the 7th period, so it has 7 orbits in its atom. Now, if you are thinking of sodium, sodium is lying in the 3rd period, so its outermost orbit has 1 electron. At the same time, it has 3 orbits. So, depending upon the period where they lie, accordingly, they are having that much number of orbits. Now, I have to explain here about the period. Already I had explained in the period, in which period they lie. Their fixed number of, now suppose 4th period, these all elements are lying. So, they all will have 4 orbits. Already I had explained. Now, suppose they are lying in the 7th period. All will be having 7 orbits in the atom. Now, one more explanation, that is, here you can see that such a zigzag line. This zigzag line is the border line for showing that which all elements are metalloids. You see here, boron, silicon, arsenic, tellurium, astatine. These all elements are metalloids. This left side of these metalloids are all metals. Right side of these metalloids all are non-metals. So here we can say Here boron, silicon, arsenic, tellurium, astatine. These all elements are metalloids. Right side of these metalloids are non-metals. Left side of these metalloids are metals. So I think now I had explained almost all details about the modern periodic table. So modern periodic table full writing is not required. At least you need to study these, the first group elements, second group elements. First group elements known as alkali metals. Second group elements are known as alkaline earth metals. Afterwards here halogens. Seventh group elements are known as halogens. Eighth group elements are known as zero group elements or noble gases. Then this is known as lanthanide series. This is known as actinide series. Then first and second group elements known as S block elements. 13 to 18 group elements are known as P block elements. These middle group elements are known as D block elements. Last two separate period, which all elements are there, separate rows, which all elements are there to them, known as F block elements. Now we will study the remaining things later on. Thank you.